Hello, chemistry students. Today we're going to be performing our molar mass of a volatile liquid experiment. So in this experiment, we're going to determine the molar mass of an unknown volatile liquid using the ideal gas law. Let's get started. Okay, so the first thing we need to do is record our pressure, and our pressure is 29.59 inches of mercury. The next thing we're going to do is take a 600 ml beaker, fill it with deionized water, and then bring it to boiling on a hot plate. And as you can see, we already have done that. Then we're going to take a clean, dry 125 ml Erlenmeyer flask, make a lid with a piece of foil, and we're going to poke one small hole with a push pin through the foil. Now we're going to determine the mass of our 125 ml Erlenmeyer flask and the foil lid. Okay, so the mass of our 125 ml Erlenmeyer flask plus the foil lid is 72.2272 grams. So the next thing we're going to do is measure about 2 to 3 milliliters of our unknown volatile liquid. We're going to be using unknown B into our 125 ml Erlenmeyer flask. Put our foil lid back on. So you can see we have our unknown volatile liquid. Now, our unknown volatile liquid is normally clear, but to make it easier for us to identify when that last drop is no longer in the Erlenmeyer flask, I've gone ahead and added just a couple milligrams of dithiazone dye. And this dithiazone is going to allow us to more easily see when that last drop of the volatile liquid is no longer in our Erlenmeyer flask. So the next thing we're going to do is we're going to clamp this and lower it into our boiling water, which is back here. Okay, so now we are going to take our 125 ml Erlenmeyer flask plus our volatile liquid, and we're going to clamp it using a utility clamp. And we're going to lower it into our boiling water. For today's experiment, we're going to be assuming that our boiling water is exactly 100 degrees Celsius. So now we need to watch for when the volatile liquid no longer remains in the Erlenmeyer flask, and we will need to remove that Erlenmeyer flask from the boiling water. Again, that dithiazone dye is going to help us determine exactly when no more volatile liquid is remaining in the Erlenmeyer flask. So you should start to see that we're actually losing our volume of the volatile liquid is decreasing now. We're just going to wait until there is no more of that liquid remaining in the Erlenmeyer flask and immediately remove it from the beaker of boiling water. So we have just a little bit of our volatile liquid remaining. We'll continue to watch for when that last drop is gone. While we're waiting, what do you call a lazy baby kangaroo? We call it a pouch potato. I got to give credit for that joke to Emily Wilson, our biology laboratory coordinator. Right, our volatile liquid is almost gone. We've got just a little bit left to go. Just a couple drops left. And it is now gone. So we'll remove it from our boiling water. And we're going to allow it to cool. Okay, so we've removed our 125 ml Erlenmeyer with the volatile liquid from the 600 ml beaker of boiling water. We're now going to allow this to cool and let the remaining volatile liquid condense back down into the 125 ml Erlenmeyer flask. Okay, so we've allowed our 125 ml Erlenmeyer flask to cool. And you can see that we have our recondensed volatile, remaining volatile liquid in the 125 ml Erlenmeyer flask. So now we're going to determine the mass of our 125 ml Erlenmeyer flask, the volatile liquid, and our foil lid. Now, before you do this, you want to make sure that you have the flask completely dry from being in the boiling water. So the mass of our flask plus the foil lid and the remaining volatile liquid is 72.5812 grams. Okay, so next we need to determine the total volume that is in this 125 ml volumetric flask. I mean, as you can see, the 125 ml mark is not at nearly the top of the flask. So what I'm going to do is take water, fill the Erlenmeyer flask to the very top, and transfer it into a 250 ml graduated cylinder to determine the accurate amount of volume that this Erlenmeyer flask holds. Okay, so I have some deionized water here. I'm going to remove the foil lid. And fill our Erlenmeyer flask with the water. You want to fill it up as high as you can go. Okay. Then we're going to transfer the water to the 250 ml graduated cylinder. Okay, so we can zoom in here. The graduated cylinder actually looks to be holding about 170, right about 176 milliliters. And that's the volume of our Erlenmeyer flask. Okay, so now that you have the total volume of your 125 ml Erlenmeyer flask, you can now use the ideal gas law to determine the number of moles of the volatile liquid that you had remaining in the Erlenmeyer flask. Now remember that we measured our pressure at the beginning of the experiment. We're assuming that our boiling water is exactly 100 degrees Celsius, which you will need to convert into Kelvin. And then you can determine the number of moles using the ideal gas law. Once you have your number of moles, you can then find the molar mass using the number of moles and the total mass of the condensed volatile liquid that you had remaining in your Erlenmeyer flask. So this concludes our molar mass of a volatile liquid experiment. Thank you for joining me.